Hello students, in previous lecture we have solved the model question paper of unit test 1 and of mathematics 1. Today we are going to solve the model question paper of unit test 1, that is for mathematics 2. Then for this unit test there are two topics. That means that unit test which will held in the September month, that for that purpose that topic number 1 and topic number 2 are there. Therefore today we are going to solve the model question paper of unit test 1 for your more practice. Then see here, first of all, here few questions which is given in this model question paper, that is question number 1. The question number which is given here, first of all see here the model question paper which is given on your screen. Observe and read the questions, examples which is given in this model question paper. Then try to solve those examples, and today I am going to discuss with you to solve those examples given in the model question paper. See here, the model question paper is given here. Then question number 1 which is given here, that is solve the following examples given below. Then the first question which is given here, find the distance between point A and B. That means there are 2 points, that is point A and point B, and if the coordinates of A, here coordinate of A is given, that is of 5, and coordinate of B which is given, that is -7. Then we have to find out the distance between point A and B. All of you studied about that, how to find the distance between 2 points using the coordinates. Then first of all see here, B, the coordinate of B point is -7 and coordinate of point A is 5. Here 5 is greater than -7. Therefore we have to find out the distance between point A and B, that is we have to subtract the smaller number from the biggest number, greater number. Therefore here 5 is the coordinate of A minus here the coordinate of B is subtracted from 5. Therefore the coordinate of B is -7. Therefore here 5 minus -7. Therefore we have to simplify this. 5 minus -7, that is 5 plus 7. Therefore here 5 plus 7, that is 12. Therefore distance between A and B point, that is 12. Then the question number, example number 2 which is given here. See here, in triangle ABC, here the triangle we have to draw the rough diagram, that is of triangle ABC, in which here angle A is given, that is of 76 degree, and angle B is given of 48 degree. Then we have to find out the angle C, and here angle A which is given here, that is of 76 degree, angle B is of given here 48 degree. Then using property of sum of measure of three angles of triangle is 180 degree, and that property we have to use here. Therefore here angle A plus angle B plus angle C is equals to 180 degree, because sum of measure of three angles of triangle is always 180 degree. Therefore, angle A, that is 76 degree, plus angle B, that is of 48 degree, plus angle C we have to find out. Therefore, 180 degree. Therefore, here 76 plus 48. See here, 6 plus 8, that is 14. Carry 1. 7 plus 5, that is 12. Plus angle C is equals to 180 degree. And therefore, here angle C is equals to 180 degree minus 124 degree. And here we get the answer, that is angle C is equals to, see here, 180 degree minus 124 degree. And therefore, see here, 10 minus 4, that is 6. Carry here, 8 minus 3, that is 5. And here, 1 minus 1, 0. Therefore, 56 degree. Angle C is equals to 56 degree. That is the answer of second example, which is given in the question number 1. Then we have to solve the question number 2 and few examples which is given in the question number 2 in the form of, that is MCQ. That means in question number 2, see here, MCQs are given here and we have to find out the proper or correct alternative of given examples. And here first MCQ, that is multiple choice question, which is given here. If a transversal which intersects two parallel lines, then the sum of interior angles on the same side of transversal is, see here, we have to again draw the rough diagram for it. Then see here, diagram is not necessary here, but we have to draw the rough diagram. There is line L and line M are parallel. Line T is a transversal of that those two parallel lines which intersects in two different points. Then here interior angles which are formed on the either side of transversal, on the same side of transversal. Then see here that angle, see here angle A and angle B are interior angles. Then see here the interior angle, sum of those two interior angles, it should be 180 degree. That means those interior angles are supplementary if the transversal intersect to the two different distinct parallel lines. If those lines are parallel, then here the property of interior angle, that is the interior angle formed on the either side of the same side of the transversal which intersect to the two different parallel lines are supplementary. That means here angle A plus angle B is equals to 180 degree. Therefore, here option C, which is given here, which is correct. That is option C, that is 180 degree. That answer, that alternative is correct answer. We will solve, that is MCQ, multiple choice question number 2. That is MCQ second from question number 2A. Here the MCQ which is given, you have to read the MCQ which is given carefully in the question paper. See here, how many lines are determined by 3 distinct points. See here, 3 distinct points, that means 3 collinear points which is given here. And that is non-collinear points we can draw here, as well as 3 lines, 3 points which may be, that is collinear points, because here only 3 points are given, distinct points. Those 3 different points, distinct points, it may be non-collinear or it may be linear. Therefore, see here, point A, point B and point C, if it is, that is collinear, then we can draw only point, that is line 1 and only 1 point can be drawn passing through this point. As well as, see here, if there are 3 distinct points are there, 3 different points which are non-collinear, then how many lines are determined by 3 distinct lines? Then see here, those 3 distinct lines we can draw the line, that is here, if those are collinear points, then here only how many lines are determined by the 3 distinct points. That question is here given here. Therefore, see here, we can't draw the line which is passing through those 3 distinct, those 3 non-collinear points, but we can draw, that is, see here, point A, B, C, we can draw line AB which is passing through only 2 points. We can draw line passing through those 2 points, that is line BC as well as line AC. That means here we can draw the 3 lines passing through only 2 points here, but we can't draw a single line, not a single line passing through all 3 non-collinear points. Therefore, here the question which is given and the options which is given here, that is A option, that is 2, or B option which is given 3, or here C option is given 1 or 3, and the last option, that is 6. Then see here if those 3 points are collinear, then we can draw only 1 line, and if those are non-collinear, then we can draw 3 lines passing through only 2 points out of that 3 points, and therefore here option which is C is correct, because we can draw 1 line or 3 lines, 1 or 3 lines, and that is the correct alternative for example number 2 or MCQ given in the question number 2A, that is in the second example. Then here we will solve the question number 2B, and that is here example which is given. Here we have to read carefully, that is point P is the midpoint of segment CD. Here we have to draw the figure or diagram for it. That means here, while solving this example, we have to draw the segment CD. Here, figure is also necessary for this solving the example. Then segment CD, and here P is the midpoint of, see here, P is the midpoint of that segment CD. That is point P, which is the midpoint of that segment CD. And here the length of CP, here CP which is given, that is 2.5. Here unit is not given, therefore 2.5 unit. We have to read like this, 2.5 unit. Then see here the CP distance which is given here, 2.5. Then we have to find out the length of CD, that is segment CD. Then see here P is the midpoint, therefore here point P is a midpoint of segment CD. Therefore here CP is equals to, that is PD, and here CP which is given here, that is 2.5. Therefore here PD is also 2.5, but here CD is equals to CP plus PD, and therefore CP which is a 2.5 plus PD is 2.5 unit. Therefore here CD, the length of CD is 5 units. That is the solution of example which is given here in question number 2b. Then from question number 3, that is example which is given here, that figure is given here in this example, then it is necessary to draw the figure which is given in the example. That is, see here, the line RP and line MS which are given here are parallel to each other, and the transversal which is given here, that is the transversal DK which intersect those two parallel lines at point H and G, and here the angle which is formed, that is we have to denote A and angle B, that means those are the corresponding angles which is given here. And here in this example, line RP parallel line MS and line DK is a transversal which intersects those two lines at point H and G, and here angle, that is DHP which is given is of 85 degree, and we have to find out angle, that is HGS. Here this angle A which is given here 85 degree, and we have to find out angle B. Then see here, angle DHP and angle HGS are corresponding angles, and corresponding angles formed by transversal on two parallel lines, those are congruents. Therefore here angle DHP is equals to angle HGS, and here angle DHP which is given here 85 degree. Therefore angle HGS is also of 85 degree. That is the example which is given in question number 3a. Then we will solve one more example which is given in the question number 3b. Then here figure which is given, that is line on which there are different points are given there, and we have to solve the examples which is based on that figure given here. Let's see here the line L which is given here, and the point T, point S, point R, and point P and point Q which is given here. Then there are few questions which we have to solve here, or examples which is given here. The question number 1, sub question which is given in the question number 3b, that is write the name of opposite ray of ray RP. See here, first of all we have to find the ray RP. See here, point R is here and RP is this ray. Then we have to write the opposite ray of that ray RP. See here, that is the ray RP, and R is the endpoint of that ray RP. Therefore opposite ray of that ray RP is, see here, ray RT. Ray RT is the opposite ray. Therefore ray RT is the opposite ray of ray RP. Then question number 2 which is given here, that is write the ray of which QR is a subset. First of all we have to focus on the ray QR. See here, ray QR which is given here, which is shown by that yellow color. See here, ray QR which is given here, and we have to write the subset of ray QR. Then see here, ray PT is a ray subset of that ray QR. Ray RT, ray PS, ray ST are the few subset of the ray QR. Then see here, the ray QR, the ray QR is one of the ray which is a subset of that ray QR. Ray QR, ray PR, ray PT, ray RT, ray ST are the few rays which is a subset of ray QR. Then that is the examples which is given in question number 3b. Then we will solve the example which is given in question number 4. Then see a few statements which are given in the question number 4. That is first statement which is given here. That is, and we have to write those statements using if and then form. That means here the first statement which is given here, the diagonals of rectangles are congruent. Then we have to write this statement using if and then. See here, if the quadrilateral is rectangle, then diagonals of it are congruent. See here, if and then which is used here to write this statement. Then question number 2, that is statement which is given here, a prime number greater than 2 is odd. A prime number greater than 2 is odd. Then see here, if any number which is greater than, if any, that is any prime number which is greater than 2, then it is odd number. That means the any number which is greater than 2, that if it is prime number, then it is a odd number. That means here if and then are used here. Then the statement third which is given here, the opposite angles of parallelogram are congruent. Then see here, if quadrilateral is parallelogram, then opposite angles are congruent. That are the example which is given in question number 4. Then we will solve the last example here which is given in the question number 5, and here the question number 4, that is the second example from question number 4. See here, figure, one more figure which is given here, and it is necessary to draw this figure to solve the examples that is given in this example, that is question number 4, second example. See here, the figure in which there is point A, B, C, D and E are there, and here angle D which is given of 100 degree and angle C which is given of 50 degree. Then we have to find out the angle ABC. Then see here angle, and here the ray which is ray BA and ray DE are parallel to each other. Here ray BA parallel to ray DE, and here angle D which is given, that is 100 degree, and angle B which is C which is given here of 50 degree. Then we have to find out the angle ABC, and here we have to do the few construction for it. That is construction which is done here, that we have to draw the line PQ which is parallel to ray AB as well as ray DE. Then construction we have to done here, that is line PQ is drawn parallel to ray BA and parallel to ray DE. Then see here, according to construction, ray DE and line PQ are parallel, and here transversal DC is considered here. Then see here, line PQ parallel ray DE and transversal which is considered, that is DC. Transversal DC is considered here. Therefore, see here angle EDC and angle DCQ, that are interior angles. Therefore, here angle D plus angle DCQ is equals to 180 degree, because interior angles, and therefore here angle D which is given, that is of 100 degree, plus angle DCQ is equals to 180 degree, and therefore here angle DCQ is equals to 180 degree minus 100 degree is equals to 80 degree. Therefore, here angle DCQ is equals to 80 degree. Then see here this angle we got, that is 80 degree. Then again see here, that is ray BA parallel to line PQ and transversal BC if considered, then this angle and this angle, that are the interior angles. Therefore, here angle B plus angle, here BCP is equals to 180 degree. But we don't know the measurement of angle BCP, but we can find out that angle using that. See here, those angles are linear parallels. Therefore, here angle DCQ, but here angle DCQ plus angle BCD plus angle BCP is equals to 180 degree. But here angle DCQ which is of 80 degree, here angle DCQ plus angle BCD plus angle BCP is equals to 180 degree. Therefore, angle DCQ which is 80 degree plus angle BCD which is given here, that is of 50 degree, plus angle BCP we have to find out 180 degree. Therefore, here 80 plus 50, that is 130 degree, plus angle BCP is equals to 180 degree. Therefore, angle BCP is equals to 180 degree minus 130 degree. Therefore, angle BCP is of 50 degree. Then see here, we have to write or put down the value of that angle BCP in equation number 1. Therefore, here equation 1 becomes, that is angle B plus BCP angle, that is of 50 degree, is equals to 180 degree. Then here angle B is equals to 180 degree minus 50 degree. Therefore angle B is equals to 180 degree minus 50, that is 130 degree. That is angle B, that is angle ABC. Here angle B means here angle ABC, which is of 180 degree minus 50 degree. Therefore here the angle which is of ABC and BCP. Here therefore angle ABC is of 130 degree, and that is the solution of given example. Then we will solve the last example, which is given here in the question paper, that is question number 5. See here, read the question which is given in the last question, question number 5. That is, we have to prove one theorem given here, that is opposite angle theorem. See here, the theorem which is given, the angles, that is opposite angles, the opposite angles formed by two intersecting lines are of equal measures, that means those are congruent, and that is the property of opposite angle theorem. Then for that purpose we have to draw the figure for it, and there is a marks for drawing figures, and therefore that is of half mark or 1 mark carrying this figure, and therefore we have to draw there. That means here line AB and line CD which intersects at point O, and here there are 4 angles which are formed here, and there are 2 pairs of opposite angles are formed. See here, angle BOC and angle DOA are opposite pair of angles, as well as angle COA and angle BOD are opposite pair of angles. Then we have to prove that those opposite pair of angles are congruent, that is of equal measure. And for this purpose we have to use the figure. Therefore first of all we have to write the given, that is, see here, line AB and line CD are intersecting lines, and line AB, line CD which intersects in a point O, that is point O, and here we have to prove that the angle AOC congruent angle BOD, as well as here one more pair of opposite angle is there, that is angle AOD congruent angle BOC, which are vertically opposite angle pairs are there. And then we can give the proof of this theorem or property using linear pair property of angles, that is linear pair angle property. Then see here, first of all, here line AB intersects line CD at point O, and here see here angle BOC and angle BOD are linear pair of angles, and therefore here angle BOC plus angle BOD is equals to 180 degree. That is linear pair of angles. Linear pair of angles. And let this equation number 1. Then see here, that is the equation number 1. And similarly, see here angle BOC and angle AOC. Angle BOC plus angle AOC is equals to 180 degree because those two angles are also, that is, linear pair of angles. Then linear, let this equation number 2. Then that are also linear pair of angles. And see here, from equation 1 and 2, see here right hands are same, that is right hand 180 degree, 180 degree. Therefore, from equation 1 and 2, we have to write angle BOC plus angle BOD is equals to angle BOC plus angle AOC. Then see here angle BOD and angle here BOC is the sum of those two angles which is at left hand side, while angle BOC plus angle AOC is the right hand side of that equation. And here in this equation angle BOC are common, therefore we have to get cancelled. And here remaining which is obtained, that is angle BOD is equals to angle AOC. That is the proof of our, that is, theorem. Then see here angle BOD congruent angle AOC. Similarly, we can prove angle AOD congruent angle BOC. We can use the same method to prove that vertically opposite angles are congruent. And that is about the model question paper of unit test 1 of Maths 2. Then you have to solve this model question paper in your notebook. Thank you.